anxiety. And this doesn't matter whether you look at a population and just say, do people that have more anxiety use more cannabis? Or if you look at an individual over time and look at, do they use more cannabis when they are anxious? Now, this is sort of a chicken or the egg issue, because notice I just said, do they use more cannabis when they are more anxious? You could also flip that around and say, are they more anxious when they use more cannabis? And so it's tricky to tease these things out. And so we're going to see that in actuality, it's kind of both. The chicken and the egg appeared at the same time. They're separate ideas. I hope it makes sense. So it turns out that low doses of THC and low doses intermittently reduce anxiety, but high chronic doses of THC are going to increase anxiety. So this is going to be a biphasic effect. It's going to be very, very important. And so you can probably already see that we could potentially use THC and cannabis to treat anxiety. However, people who use cannabis recreationally or abuse it may in fact increase their anxiety levels. So how does this work? And so we're going to start with the CB1 receptor. And so low doses of THC are going to preferentially inhibit glutamatergic neurons. So these are excitatory neurons that release glutamate and cause anxiety. So if we inhibit glutamatergic neurons, we inhibit the release of glutamate, and we inhibit or decrease anxiety, and we have a very happy cat. However, at a high dose of THC, we are also going to inhibit GABAergic neurons. GABAergic neurons are inhibitory neurons that release GABA. GABA decreases brain activity to decrease anxiety. So if we inhibit GABAergic neurons, we decrease GABA release, which causes an increase in anxiety, and we have a scaredy cat. CBD also has a biphasic effect. However, it is entirely different. The mechanism is entirely different. Low and middle doses of CBD are actually going to activate the serotonin receptor. Increased serotonin is going to reduce anxiety, and again, we have our happy cat. High doses of CBD, though, activate TRPV1. TRPV1, through an unknown mechanism, is going to actually sort of increase anxiety. Now, it's tricky because anxiety is going to increase, but it's going to increase from the decreased level due to the activated serotonin receptor. And so the net is no change in anxiety, and we have an indifferent cat. So that is its general effects on anxiety. Something related to anxiety is aversive memory extinction, which is involved in post-traumatic stress disorder, which is probably where you're more familiar with it. So aversive memory extinction involves the ability of our brain to forget bad experiences so that we don't overact in non-negative situations in the future. And so we have an experiment here that I think is going to help illustrate this for you. So if we take a control mouse, and at the same time, we make a sound, and we give the mouse a shock. The first time, the mouse doesn't know that the sound is going to signal a shock, and so they don't react to the sound. But the second, the third, the fourth time, the mouse knows. The first time I heard that sound, I got shocked. And so, if we do it the second time, the mouse hears the sound and knows the shock is coming, and they react to it. After a few times of that, though, the mouse starts to associate the shock with the sound. And so, if we then do just the sound, the mouse is going to flinch, assuming it's going to get shocked, even though it doesn't. However, if we then, without shocking, play the sound a few times, the mouse extinguishes the aversive memory. And so it then stops flinching at the sound. And so we see it starts flinching, but after a few times of the sound but no shock, it stops flinching. A mouse with PTSD will not extinguish this aversive memory. After the first shock, it continues to flinch every time you play the sound, regardless of how many times you play the sound without a shock. It is indifferent. Not indifferent. It is, I don't know what the word I'm looking for, but it goes on indefinitely. So this is a model of PTSD. Imagine a situation where you have some sort of an accident that involves a loud bang. For the next day, maybe the next week, every time you hear a loud bang, you may jump, even though there is nothing bad happening to you. However, after a while, you stop jumping every time you hear a loud bang. However, if that first experience was so traumatic, such as a veteran coming back from a war, they may never forget that first memory. And so for the rest of their life, and every time they hear a bang, they start to have flashbacks and panic attacks, which is probably where you're familiar with PTSD. Interestingly, in a mouse model, if we simply knock out the CB1 receptor so that we have a CB1 null mouse, it completely mimics PTSD in these mice. They learn to flinch when they hear the sound, but they never forget to flinch when they hear the sound. And so it appears that the endocannabinoid system is important in memory extinction, but not the learning process to begin with. We also see this in general learning extinction and not just aversive memory extinction. So here we're going to have mice in a maze. And so the mouse is going to be put into the maze and it's going to find the cheese. Okay, so initially we're going to watch trial 1 on the left side here. If I put the mouse, come on little mouse, go, there he goes. And so he's going to run around the maze until he finds the cheese. And now he is happy. If we put the cheese in a different location in the maze, whether this mouse is a control mouse or a CB1 null mouse, it doesn't matter. The mouse remembers where the cheese was the first time. And so he is going to go initially to the back left corner of the maze where he expects the cheese to be. But when it's not there, then he's going to run around until he finds where the cheese actually is. And so he goes where the cheese was the first time, and then he tries to find the cheese the second time. So right now, the endocannabinoid system has had no effect. The mouse learned where the cheese was supposed to be. Where we see a difference is on the third trial. Now this time, the cheese is again in the back right corner. This is the same place it was in trial number 2. The control mouse remembers, the last time I did this, the cheese was in the back right corner. And so I am going to go straight to the back right corner and find the cheese. And this time the cheese is in fact in the back right corner. However, the CB1 null mice is unable to overwrite the initial memory. And so the CB1 mouse doesn't remember that the cheese is now in the back right corner. It still thinks it's in the back left corner. And so again, it goes to the back left and then runs around until it finds the cheese. You can do this 100 times, and every time the mouse is going to still expect the cheese to be in the back left corner. And so the endocannabinoid system appears to be involved in learning extinction, overwriting a previously learned idea or fact. So obviously, this opens up all kinds of doors that we can use to treat problems. We can use this pharmacologically. If we introduce an FAAH inhibitor, which increases the endogenous AEA levels, this actually increases learning and aversive memory extinction, which is a good thing. Additionally, if we pre-treat the mouse with an antagonist of the CB1 receptor, we can prevent this increased AEA from having an effect, which kind of confirms that this is working through the CB1 receptor and not some secondary mechanism. Experiments with 2AG have given contradictory results, and we still need to figure out its role here. THC and CBD in human experiments show increased fear extinction. So if we essentially do the same experiments we just showed with the mice in humans, but we obviously can't knock out the CB1 receptor in humans, so instead we give them THC and or CBD, and we see that activating the endocannabinoid system increases this extinction process. We are not going to induce PTSD in a person in the name of science. However, unfortunately, there are plenty of people that already suffer from PTSD from a number of different traumatic experiences. And if we look at cannabis use among PTSD sufferers, we see that cannabis use is higher amongst those sufferers. Again, chicken or the egg, is the cannabis helping relieve the PTSD symptoms, or is the cannabis kind of potentiating and causing the PTSD symptoms? Based on other experiments, it appears that most likely these PTSD sufferers are using cannabis to self-medicate. We can see that if we give THC to people who suffer PTSD, they have fewer nightmares, they have fewer flashbacks, and they report increased sleep quality. We've only done short-term trials, and so what the effect of this is going to be long-term, we don't know. Is there going to be sort of tolerance built up and the PTSD is going to come back? We don't know yet. No CBD clinical trials have yet been done in the treatment of PTSD. So let's move on from anxiety and move to sort of a related emotion, which is stress. When we talk about stress, we have to talk about the hypothalamus pituitary axis, or the HPA. And so in this axis, the hypothalamus, which is a region of the brain, releases corticotropin releasing hormone, which then migrates to the pituitary gland, which releases adrenocorticotropic hormone, which makes its way to the adrenal glands and the adrenal cortex. The adrenal cortex makes cortisol, which is the primary stress hormone. It causes the symptoms of stress. However, when the cortisol gets into the bloodstream, it also comes back to the hypothalamus and the pituitary and has negative feedback effects there. If we look at HPA axis activity in people, we see that higher levels of this stress activity correlates with depression. And so here, we are going to kind of connect stress and depression. Now, obviously, those are two different ideas, but they are actually connected somewhat. And so what is the role of endocannabinoids in this? And so we have 3 balance beams here. The first one is the basal normal level. And so if you're taking notes, please take notes here. I didn't have a good way of making this balance beam level. Okay, so I'm telling you right now that this balance beam should be drawn level. In basal experiences, the amount of stress from the HPA axis balances out with the levels of AEA, and stress levels stay constant. The activity of the HPA axis stays constant. However, when we suffer from acute stress, expression of AEA goes down. And so the stress takes over and we suffer from increased activity of the HPA axis. If the stress sticks around a long time, though, AEA levels stay low. But now we express extremely high levels of 2-AG. And remember that 2-AG is a stronger agonist than AEA. So in this situation, we're going to essentially kick in a negative feedback loop to reduce our stress level. When we have chronic stress, the endocannabinoid system is supposed to bring us back down to normal so that we don't undergo exhaustion from stress. However, we know medically and from personal experience possibly that we do in fact suffer from burnout due to stress. And so what happens is a lot of times we end up developing tolerance to these endocannabinoids, and then the stress again becomes the heavier side here. Clinical trials and experiments here using cannabis rather than endocannabinoids have been all over the place. We see some situations where it helps, some situations where it doesn't. If we look at giving cannabis and THC to people, we see a spike in HPA activity or increased stress in people that do not frequently intake cannabis or THC. However, if we give them to people who do chronically take cannabis or THC, we don't see a spike. However, the basal stress levels in these people are generally higher than in infrequent or non-users. If we give THC to adolescent rats, what we see is that they are more likely to develop depression in adulthood. And so this may not have a dramatic effect immediately, but it's predisposing these rats to depression later in life. CB1 receptors are downregulated in the presence of THC. And so we think that that downregulated CB1 receptor causes a aberrant or incorrect development of the neuronal system, the nervous system, which then leads to depression later in life. What we have seen that is even once the CB1 receptor is downregulated, if we give a positive allosteric modulator of CB1, it allows the body to better make use of the endogenous endocannabinoids, and that then reduces depression. We see a correlation between adolescent cannabis use and adult depression in adults. However, there are a number of confounding factors that make it somewhat questionable. It appears actually that there is a shared genetic predisposition, meaning that there are genetic cues that, number one, increase cannabis use in adolescents, but also increased rates of adult depression. And so it is likely that there is a direct link between cannabis use and depression, but it's very, very hard to tease out because people who use cannabis are more likely to use cannabis are also more likely to develop depression even if they don't use cannabis. And so luckily I'm not the one who has to sort this out. So that is the end of that chapter. I hope you found it interesting. When you're ready, go ahead.